Hello guys, how are you all? I hope you all are good and fine. So this is me and I welcome you in lecture number 4 of our chapter electricity. Let's begin this lecture without wasting our time. So in this lecture, we will study about the resistivity. What we will be discuss? We will discuss resistivity that is very important. So yet we have seen resistance. Now lots of students get confused between these two terms, resistance and resistivity. Now, what is the point of confusion? Basically, these both terms related to the opposition of current. These resistance also oppose current, resistivity also oppose current. Then what is the difference between it? So definitely we will try to understand by the derivation. So what is our resistance? Resistance is basically oppose the current and it is proportional to the length and it is also inversely proportional to the area. Now if I write it combining, then I can write resistance is proportional to the L upon A. Okay, I can also write it like this. Now guys, if I have to remove this constant, sorry, if I have to remove this proportionality, then I will replace it with equal to sign and also I have to add a constant. And in this case, the constant is rho L by A. So this rho is what? This rho is the resistivity. This is the resistivity. Okay. I hope guys you understand this. Now, what is the formula to calculate resistivity? Let's send L here and A here. So this is the formula to calculate resistivity. I hope guys you got my point. Now let's move on to the next slide and let's try to understand the definition of the resistivity. So resistivity is the ability of the material to resist the flow of current. So basically, when I talk about resistance, so resistance was the ability of the conductor. Ability of what? Conductor. It can be made up of any material to resist the flow of current. And here in this case, the conductor can be made of any material. Any material. Okay, guys. So, but if here I am talking about resistivity. So, resistivity is also the ability to resist the flow of current, but it is the ability of material. This is very important. Resistivity, resistivity, the ability of the conductor, sorry, the material to resist the flow of current. Flow of what? Flow of current. Okay, guys, I hope you got my point. Now, let's talk about the SI unit of resistivity. So, SI unit of resistivity is ohm into meter. Now, how did we calculate this SI unit? So this is very simple. We, we can derive it by the formula. We know that resistance is rho L by A, where L is length, A is area, and this rho is resistivity. Okay, and this is what? This is resistance. Okay, so guys, what happened here? I will simply calculate the formula for resistivity, and that is R A by L. And this R, the SI unit of this R is ohm, and the SI unit of area is meter square, and the SI unit of this length is meter. Now, if I cut this meter from this meter, then it will remain ohm into meter. So this is the SI unit of the resistivity. So I hope guys you understand this point. Now, resistivity is that of material. It is related to the material. On the other hand, a resistance is related to the conductor. Okay, because resistivity means every material has its specific resistivity. Okay, it will not be depending on length and area, but on the other hand, our resistance will be dependent on the length and the area. We also saw this in our previous slide, that if the area is higher, then the resistance will be lower. If the area is lower, then the resistance will be higher. Okay, and we also saw that resistance is also dependent on length. If the length is higher, the resistance will also high. If the length is lower, then the resistance will also lower. But here in this case, the resistivity only depends on the material, by which material the conductor is made up of. It doesn't have anything to do with length and area. Now, after understanding this concept, let's move on to the next slide and let's try to understand, if you are asked what is the difference between resistivity and resistance, then how would you write it? So basically, the first difference between resistance and resistivity is that ability of conductor to oppose the flow of current is resistance, but ability of the material to oppose the flow of current is resistivity. And we can also say the second point, that resistivity does not depend on area and length. On the other hand, resistance depend on the area as well as length. So this point is very important. So guys, after understanding this, let's move on to the next slide and let's try to understand what is there for us. So here the same thing is written, that resistance depends on the resistivity. So it is very important that resistance is dependent on the resistivity. For an example, if this is a wire, and let's suppose the length of the wire is given and the area of the wire is also given, then you can calculate the resistance. Okay, if the resistivity is higher, then the resistance will also high, because a resistance is dependent on the resistivity. Okay, but its opposite statement is not correct, because our resistivity does not depend on resistance. Resistivity does not depend on resistance. For an example, let's suppose this is a wire of length L. Okay, let's suppose its resistivity is rho. Now, if I also take another wire, and this wire is made up of the same material. Let's suppose this is wire first, this is wire second, and these wires are made up of the same material, and let's suppose its length is 20 centimeter. Now the resistivity will remain same. Here also, in this case also, the resistivity is what? Rho. Okay, let's suppose its resistivity is 20 ohm meter. Then here also the resistivity will be 20 ohm meter. It is not going to be changed. And why it is not going to be changed? Because resistivity does not depend on the resistance. So now the question here before us is that on which our resistivity depends. On which does our resistivity depend? So I will write that our resistivity only depends on the material. Okay, I hope guys you got my point. And the other thing also, it also depends on the temperature. Okay, it also depends on the temperature. So you have to memorize this point. Now guys, let's move on to the next slide. So guys, in this slide, we will discuss a question. Okay, this is question number 1. And let me read out this question for you. So find out the resistivity of a conductor of 2 meter length and 6 meter square area. The resistance of the conductor is 4 ohm. Okay, so when I start to write the solution of this question, okay, then first of all, what will I have to do? I have to write down the given data. So let's see what values have been given. So the first value is length. Okay, here we have been given the length of the conductor. So what is the length of the conductor? Length of the conductor is 2 meter. Okay guys, I hope you get my point. Now the other thing is area. We also have been given the area, and the area of this conductor is 6 meter square. Let me raise it. So area of the conductor is 6 meter square. Now what we also have to do, we also have to write down the value of resistance, because in the last lines you can see that the resistance of the conductor is 4 ohm. So I can write it 4 ohm here. Okay guys, I hope you get my point. Now let's find out the resistivity. So we know that the formula of resistance is R is equals to rho L upon A. Okay, so by this formula we can calculate the resistance. Okay, but here we are not asked resistance. Okay, we are asked for the resistivity. So how can I get the resistivity? If I cross multiply this here, and if I cross multiply this length here, then I will get the value of rho, and that will be RA by L. That will be what? RA by L. So if I put the value of R here, it will be 4.
If I put the value of A, that is 6, and the value of L is 2. Now if I cancel it out, it will cut it 3 times. Now 4 3s are 12. So basically the value of resistivity is 12. Okay, but I cannot leave it 12 only. I have to add its unit as well. So what is the unit of resistivity? The unit of resistivity is ohm into meter. Okay, so this is my right answer. It can also be written as 12 ohm meter. Okay, so this will also be right. So I hope guys you understand the solution of this question, and this question is nothing, it is just based on the previous concept which we have seen in this lecture. Now guys, let's move on to the next slide and let's try to understand what is there for us. So basically here we are, and here we will study, or we will see a question. So find out the resistance of a conductor which length is 10 meter and area is 5 meter square. The resistance of conductor is, the resistivity of a conductor is 5 ohm meter. So again we will do the same thing. We will simply write down all the data which we have been given. So we have been given, okay. So first thing is the length. So the length is 10 meter. Okay. And the second thing given in this question is the area. And the area is 5 meter square. Okay. And we also have been given the resistivity. And resistivity in this case is 5 ohm into meter. Okay, so this is resistivity. Now I know the formula of resistance. And what is the formula of resistance? R is equals to rho L by A. Okay, this is the formula of resistance. Now I can simply put all these values in this formula and get my answer. So what is the value of resistivity? Value of resistivity is 5. And what is the value of length? The value of length is 10. And what is the value of area? That is also 5. So this 5 will cancel out by this 5, and our answer will be 10. Now, should I write only 10 or 10 ohm? I will have to write 10 ohm because 10 has no meaning. Only 10 has no meaning. But if I add unit of it, then definitely it will have some meaning. So don't forget to write unit with their values. So R is 10 ohm. Okay, this is our answer. This is my what answer. Now guys, let's move on to the next slide and let's talk about other questions. So basically, what is the effect on resistivity if we double the length of a wire by stretching it? So basically, this is very important question, and this question needs our conceptual understanding. If we have a clear idea about concept, then definitely we can solve this question. Okay, so most of the students gets confused. Let me tell you how can they be confused. We know, everybody know that the value of R, or you can say the formula for resistance is rho L by A. Okay, rho L by A. So if you move this A here, then this will give you this formula. Now I tell you what you can think, that this resistivity is dependent on this area and this length. Okay, So for your kind information, I want to let you know that this resistivity does not depend on area, either on area nor length, okay, or nor resistance definitely depends on resistivity, but resistivity cannot depend on area and length, or might be resistance. Okay, it will only depend on the nature of the material. It will only depend on the which type of material you have taken. Okay, for an example, let's suppose you took copper. Okay, so this is a wire of a copper. Now, if I calculate resistivity, let's suppose this is 10 ohm meter. Now, if I increase the length of this copper, then also its resistivity will be same. It will remain same, 10 ohm into meter. It is not going to be changed. So resistivity cannot be changed. It will only change if you change the material. For a same conductor, resistivity do not change. Now, let's talk about this second question. Okay, let me write down before moving ahead. Let me write down resistivity does not depend on area, comma length, comma resistance. Okay, guys. Now, let's talk about the next question. And this question is saying that what is the effect on resistivity if we double the area of a wire? So, this is again a same question. This is again a same type of question, and our answer will be same, that the solution of this question number second is resistivity will remain what? Same. So resistivity will remain same even in this case. So I hope guys you understand my point. Okay. Now let's move ahead. Let's move ahead, guys. Okay. So here we are. This is again a question in front of us. So basically, let me read out what this question is saying. So what is the effect on resistance if we increase the length of a wire by 3 times and decrease the area by 6 times? Okay. So now we know that resistivity do not depend on resistance, but resistance depend on the resistivity. Now how can they be dependent? We know the formula that resistance is equals to rho L by A. Okay. Now let's use this formula to solve this question. So here they are asking us about the resistance. So let's suppose there is a conductor whose resistance is R. Okay. Now what we have done, we have basically increased the length by 3 times. So this formula, if I write this formula, let's suppose this is the formula for the resistance R, and this is the formula for the new resistance. So how can I write new resistance? In new resistance, the length is increased 3 times. So I will write 3L instead of L, because L is increased by 3 times. Now instead of A, this A is for area. Okay, this is for area. So here it is written that area is decreased by 6 times. Area is decreased by 6 times. So let's suppose in this condition the area will be A by 6, because it is decreased by 6 times. Now what about resistivity? So as I told you that for the same conductor, resistivity will also be same. So that's why the resistivity will remain same, and you can directly write it like this. Now if you solve this, then you will get that 3L row, this 6 will go upside and it will give you this value, and if you solve it, it will be 18 rho L by A. Okay, I'm writing it here that R new is equals to 18 rho L by A. Now what is this rho L by A? This rho L by A is the value of the previous resistance. Okay, or you can say this is the value of the old resistance. So you can directly put, instead of this, you can replace this rho L upon A by R. Okay, so now this is a answer that R new is equals to 18 times of R. So this R new is equals to what? 18 times of R. I hope guys you understand my point. Now let's move to the next question, and that is, what is the effect on resistance if we double both the length and the area of a conductor? So basically here also, to write down the solution of this question, I will do the same thing, that here it is asked that if we double the resistance, okay, sorry, if we double the length and the area, then what will be the effect on resistance? So first of all, let me write down the previous value of resistance. So the previous value of resistance will be rho L by A. Okay, now let me write the new value of resistance. So this will be rho, because resistivity cannot be changed until we change the material. Okay, so rho is equals to, so rho will remain same, but this length is just being double. Okay, so that's why I can write, instead of L, I can write 2L. And we also double the area of conductor. So it means in this case the area will also be double. Okay, so this is the value of R new. Now this 2 will be cancelled out by this 2. So now this will be giving us rho L by A, and this rho L by A is the value of R old. Okay, so in this by solving this you know the solving this formula, we can get that our R new is equals to R old. It means in both the condition our resistance will be same. So I hope guys you understand these questions. Okay, so that this was the last question, and I hope you understand this lecture. Thank you so much. See you later.